Welcome to Beta Online Learning. In this video, we present the surface areas and volume of a right circular cone. First of all, let us see the concepts. This is a topic, a subtopic on the major topic, surface areas and volumes for the 9th standard CBSE Mathematics. First, let us go to the concepts. In this figure, you see a right circular cone. First, let us see what is a cone and what are its parts. Let us see. The cone has a circular base. The base is a circular cross section and it has a vertex or the apex. It's also known as the apex, the pointed portion at the top. It has an axis, a line segment which is perpendicular to the radius or the base of the base. It is perpendicular to the base. In the case of a right circular cone, the axis is perpendicular to the base. If it is not a right circular cone, it will be inclined at an angle. But we will consider only a right circular cone as it is in the syllabus of the 9th standard secondary grade syllabus of the CBSE here. So we'll be dealing with right circular cone in which the axis is perpendicular to the base. Here you can see that radius, the center of the base is here. This is the entire circular cross section. It has a circular base. And this axis, which is perpendicular to the radius or the base, is the height of the cone. And the slant height of the cone is this portion, the slant height. These are the parts of the cone. And let us explain all these things. First of all, the parts of a right circular cone, the vertex or apex, it's also known as apex, the sharp tip aligned above the base. The radius represented by small r. It is the distance between the center of its circular base to any point on the circumference of the base. It's nothing but the radius of the circular base. Next one is height. The height h, the axis coincides with the height. The axis is actually the line segment which is perpendicular to the base, as we already saw in this figure. See, this is the axis. And that is perpendicular to the base or the perpendicular to the radius of the base. And it is the perpendicular distance, the height represented by small letter h. It is the perpendicular distance between the vertex and the center of the circular base. Slant height, which is usually represented by the letter small l, not s, but small l. Usually here in all our problems, we will use the small letter L for representing the slant height. It is the distance from its vertex to the point on the outer edge of the circular base. This point. This to this outer edge, this distance. Slant height is usually represented by the letter L, the small letter L. A typical example of a right circular cone is an ice cream cone. It is an inverted right circular cone. We can achieve a right circular cone by rotating a right triangle about one of its leg except the hypotenuse. Thus, the perpendicular leg is also known as the axis of rotation. The triangle's hypotenuse is the slant height of the cone. It generates the lateral surface area of the right circular cone. Lateral surface area is also known as curved surface area of the solid shape. The previous classes we have already seen in 8th grade, three-dimensional shapes, solids, cube, cuboid, and cylinder in 8th grade. So now in 9th grade, we are going to see cylinder, I mean cone and sphere, hemisphere, and so on. So in this video, this is the first part of the surface areas and volumes chapter. We will see surface areas and volume, surface area and volume of a right circular cone. You see the right triangle is being rotated about its axis as one of the legs of the right triangle, and it is generating a solid shape of a cone with hypotenuse as the slant height. The formulas to remember in this chapter are: curved surface area of a cone is given by is equal to pi RL. Total surface area of cone is equal to pi RL plus pi R squared. You take pi R outside, you get is equal to pi R into L plus R. Then we have volume of cone is equal to 1 by 3 pi R squared H. The relationship between radius small r and height small h and the slant height L is given by an important relationship which comes as a result of the Pythagorean's theorem, the theorem of the Pythagoras. So we have in a right angle triangle. So L square is equal to R squared plus H squared, from where we can get L is equal to square root of R squared plus H squared. Or we can also, here there is, wait a minute. H, and this should be R. From this formula itself, we can get this equation, we can get the values of H and R, H or R. We can either get H in terms of L and R or R in terms of L and. So these are three important formulas for this chapter to solve problems in this chapter. These are the concepts. If not mentioned in the question, we can take pi equal to 22 by 7, which is only an approximation. Since pi is not a rational number, it cannot be represented in the form of p by q, where p and q are integers. So it's only an approximation. But for easier calculation, that for the values given in that particular question, this might be easier for calculation. So we can assume that it is 22 by 7. If nothing is mentioned in the question, we can take pi is equal to 22 by 7. But in some questions, the value of pi will be mentioned as pi is equal to 3.14, which again is also an approximation because pi is an irrational number. It moves on, it goes on and on, decimal expansion, randomly. It doesn't terminate. So we take only up to 2 decimal places as an approximation for easier calculations. Hence, we have now covered the concepts. Now let us move on to the textbook. Now let us have a look at the textbook. See here, these are the formulas covered. In your textbook, you'll find certain worked examples. You please go through those worked examples, especially these examples where height is given, the base radius is given, the curved surface area you have to find, and the total surface area of the cone. We use the formulas. Since height and radius is given, see here in this question, only the height and the radius is given, but we do not know the slant height. So we can find the slant height. L is equal to square root of 16 squared, the radius squared, the height, h squared plus radius squared, h squared plus r squared. We use that relation between L, h and r. So L in terms of h and r, we can get it here as 20 centimeters. Then we apply this in the formula pi RL, the curved surface area, using 3.14 for the value of pi. So here we get the value, the total, the CSA, the curved surface area. The total surface area, or TSA, will be equal to pi RL plus pi r squared. Or you can use directly pi r into L plus R. Anyway, you'll get the answer. So these are the worked examples. And here, especially, the fifth question is slightly twisted. So we will be discussing this in detail. Rather than other questions, I just go through the other questions. Diameter of the cone directly is given, slant height is given. So the first question is quite easy. Its curved surface area is just directly pi RL. Second question again, total surface area is, but we do not know the radius, the height. Here we just, the slant height is given. So no need of height. So total surface area is, pi RL plus pi R squared. Diameter is given, so you have to divide this 24 by 2. Its radius is 12 centimeters. Be careful with the units and also read the question carefully to note the value of pi, whether it is mentioned or not. So here in all these first 4 questions, you can take pi is equal to 22 by 7. Fourth question, of course, here also the curved surface area is given. See, the third question, the curved surface area is given. So you can use the formula for pi RL and equate it to 308. Pi RL is equal to 308. Slant height is equal to, is given. So we can find the radius. R is equal to the 308 divided by pi L. That's all. Pi into 14. That's all. That is very easy. In fact, if you take pi equal to 22 by 7, the calculation will be very easy. You can try them out. Total surface area is, of course, pi r L plus pi r squared, or pi r into L plus R. Once you know radius, you can find the total surface area also of the cone using the formula. The fourth question, again, you can take pi equal to 22 by 7 here. Slant height is to be found out. Given the height as 10 meters. So what will be the height of this cone? Let us say, what will be slant height of this cone? Height is given, h is equal to 10. So slant height is equal to, let us calculate, square root of h squared plus r squared. H squared is 100, square root of 100 plus 24 squared is 576. So you'll get 676 on the whole inside the square root. Please be, a square root of 676 is 26. So you'll get 26 meters as a slant height. These values, some of them you can even memorize them. So 676, 625 square root, you all know. It is 25. So the next perfect square is 676. And it also comes as 6, 6 or 36, not 26. The 6, if the number ends in 6 in 8th grade, you know about squares and square roots. So you can apply those ideas here. Your cost can be found out after finding the CSA. Since the canvas required for the tent is only on the curved surface area, we don't put the canvas on the ground. We don't spread the canvas on the ground of the tent on the floor. So we only do the roof, that is the conical part. So CSA of the tent is the canvas required, the area of canvas required, and thereby pi RL and into 70 rupees per, is the cost of the canvas required. Next, coming to the fifth question, I will work out this in detail because there is a small twist in this question. Not a small twist, but just a little bit you should understand. What is the length of the tarpaulin? 3 meters wide. Usually what we do is we take a tarpaulin sheet of paper, rectangular sheet of paper, cloth, canvas cloth, tarpaulin or canvas to make the tent. So a conical tent is made from this rectangular sheet. Let us now go to the working of this. See, length of the tarpaulin is what they ask. It is having a uniform width of 3 meters. So let's go on to the solution. See, in this question, we are given the length of the sheet. We have to find the length of the sheet. So let us draw a shape to be a rectangle. So this is assume that this is a sheet of the length. We don't know the length of this sheet, and we have to assume the length of the sheet. The breadth of the sheet, the width of the sheet is given. Tarpaulin is given. It is 3 meters. So here it's 3 meters. Let us assume that this is 3 meters. And we form the rectangle. They have asked the question, we are assuming to be rectangle because they've asked us to find out the length, and the width is given. So we assume tarpaulin. The length is not given. So length is to be found out. It has a width. So it's a rectangular. We can assume like that. So this part is the 3 meters. This vertical part, vertical length is called 3 meters. So just a minute. It is so we have here, this part is the 3 meters. We need to find out the length of this. Let the length is not known. It is no harm in assuming the length. You can assume the length is x meters. We can assume this as x. And we can assume this as x meters. Okay. So let us assume that this should be x meters. Now, the problem becomes simpler now. We are given the height of the cone. Height is 8 meters. And the base radius is given as 6 meters. So we need for CSA, what do we need? We need the slant height. So first of all, we have to find the slant height. To find the CSA, so slant height of the cone, conical tent, let us say, is equal to, let us find out this. We are given, what are we given? We are given the, this is L actually. We have to find L, isn't it? So L is equal to, we apply this formula directly. We are given the radius. Base radius is 6 meters. Height is, H is given. R and H are given. So square root of R squared plus H squared. We make use of this formula. So R squared or H squared, let us say. Whichever possible, H squared plus R squared. R squared. So this is how we proceed. And we can substitute the values here. So what are these values? You substitute it here. So you will get L is equal to R, H is given as 8 meters. In the question itself, it is given that H is the height is the 8 meters. So we can put it as 8 squared. And the R is given as 6. So we can put it as 6 squared. On simplification, we get square root of, write it as square root of 8 squared. This is 8 squared. So this is 8 squared. We'll put it as 8 squared there. So 8 squared is 64. So 8 squared is what? 64. And what is the 30? This is plus 36. 6 squared is 36. You will get 100 there. So this is equal to square root of 100. What is square root of 100? Is 10. So square root of 100 is equal to 10. You will get 10 meters. So this is the slant height of the conical tent. Now, once you know the slant height, you can easily find out the CSA. So CSA of cone is equal to CSA of the cone can be found using which formula? Pi RL. So you can easily find out the pi RL here. You can find the pi RL here. We use 22 by 7 over here because no mention is made in the question regarding this one, isn't it? So we have not been mentioned whether the so here pi. We mentioned the pi RL. So that is equal to what? Is 22 by 7. 22 by 7. We will write it as 22 by 7 into yeah. R is 6 here. We will make it bold. Yes. L is what we calculated now. It is nothing but 10. So we or is it given as 3.14? Oh, sorry. We have to take it as 3.14. Why? Because yes, because it is 3.14. Pi is equal to not 22 by 7, it's 3.14. It is given in the questions. Sometimes we miss that detail. It is very, we must be very careful here to note that pi, whether pi is mentioned or not in that question. So pi is equal to 3.14 into 6 into 10, 31.4 into 6. That's all. Very easy calculation, 31.4 into 6. That is equal to 31.4 into 6. You can calculate and put it there. So we will be getting here the value of the one 188.4. It will be meter squared. So we got this question I'm working out in detail because there is a small catch in this, which you have to understand. So meter squared, we got the CSA of the cone. This is the effective cloth area, tarpaulin area. In this rectangular sheet, the area of this rectangular sheet will be 3 into 3x. That's all. But this we cannot equate this 3 into x, 3x to this directly because there is a, as seen in this question, we have a wastage, cutting and extra length of the material that will be required for stitching margins and wastage in cutting. So after cutting only we get, so 20 centimeters is being wasted out. So cut from this. So the length, width doesn't change. Width will not change. Only the length will have to be modified in here. There's some margins that are required. So we assume that we take it from the length of this x. So x minus, so as we move on, here we will come to this part. So we have this this equation here. So we have it like this. So x minus, within brackets we write x minus 0. Why we take 0.2? Because it's 20 centimeters. We have to convert it into meters. 0.2 into 3. 3 meters the width of this. So L into B, area of rectangular cloth, the tarpaulin, that is equal to 188.4. This will have to solve for x. Yeah, that's all. So let me do that solving here. You can easily do that. 3x minus 0.6. It comes to be a whole number there. Is equal to 188.4. And that is 180 plus 0.6. Of course, it becomes, here it is equal to 189. This is the, sorry, this is not equal to, is equal to 184. So after this, what happens is, this is, the next part is 3x is equal to 189. We are adding this to, so 188.4 plus 0.6. This should be the next step. So equal to 189. 189. Thereby we get we get 189. So 3x is equal to 189. We get so what will be the value of x? That's all. Calculate the value of x. 63. That's all. On dividing by 3, we get x is equal to 63. Equal to 63 meters is the correct answer. The length required. So this ends the first part of our, that is, surface areas and volumes. And the other questions, of course, are similar. When you, the only one question I have solved here, just because it's twisted here. The other questions are quite easy. When diameter is given, you have to get the radius. When height is given, you have to find this slant height. The 8th question is similar to that, but hollow cone, which means the only CSA you have to find. Hollow cone doesn't have a base. The base part is not filled; it is hollow. So the only the CSA has to be found in the 8th question. Now coming to the volume of cone, let us jump to the volume of cone now, because the textbook says here the cylinder and everything are being covered. Volume of the right circular cone is a very easy one. Just you can, the formula for volume of a cone is 1 by 3 pi r squared h. Here, of course, if you are given the slant height, you have to find the h. That's all. H is equal to, see here, if you are given the height, you have to find the radius. If you are given the radius, you have to find the height. Here, this example here given here is, just go through that. You will find it easy. See, this example is also important, where the stitching margins and cutting and all those things. You have been asked to find the first. In this example, Monica has a piece of canvas whose area is 551 meters squared. That means it is having some, the area of the canvas is given directly. Here it's in the previous, here she uses it for making a conical tent. The base, with a base radius of 7 meters. Assuming that all just a minute. We will go back to the textbook now. We should have taken that page on the textbook. This in the volume of cone. The volume of cone is equal to 1 by 3 pi r squared h. And it is given as 1 by 3 pi r squared h. H is where r and h will be given usually. If r and h are not given directly, suppose L is given instead of that. L and h are given, then you have to find r. Then only you can find the volume. In this particular case, in this example, Monica has a piece of canvas 551 meters square. She uses it to make a conical tent with a base radius of 7 meters, assuming that all stitching, the stitching margins and wastage incurred while cutting amounts to approximately 1 meter squared. So this 1 meter squared will be deducted from this cloth, from this canvas, to become the effective curved surface area of the conical part of the conical tent. Because it's is removed from the cloth. So the effective CSA of the conical tent will be only 550 meters squared. And the required base radius of the conical tent is given as 7 meters, r equal to 7. There is no covering in the floor, only the conical. It is only the conical part of the tent is being made of canvas. That you should understand. So that is why we take only the CSA, only a curved surface. Now moving on to the curved surface area of the tent, pi RL is equal to, directly we can get the L from here. Pi RL is equal to 550, 22 by 7, because there is no mention in the question about pi. So we take it as 22 by 7 into 7 into L. So directly we get 22L is equal to, we get 25 meters, 550 by 22, 25 meters. Directly L is 25. So we can get h from here, because we need h for the volume, the vertical height. So h is equal to root of L squared minus R squared, and thereby we get root of 576, which is nothing but 24 meters. Then use this h in the formula 1 by 3 pi r squared h to calculate the volume. That's it. In meter cube, the unit of volume is cubic meter or meter cube, or centimeter cube, cubic centimeter. These are the, and you be careful with the units when you go through this exercise. There are 9 questions in this. There is one question or 2 questions rather. There are some twisted questions. You can just try them out. If any doubt questions are there, please comment, mention the question number, exercise number and question number in the comment box, so that we could discuss that in our online sessions, live sessions. Okay, volume is, here we have covered so far in this video. Cone, the right circular cone, the surface area and areas and volume of a right circular cone. In the next video, we will see sphere and hemisphere. Thank you.